All right, class, now we're going to do some examples over cross product problems. So I'm going to post a cross product that you can solve. So find V. So we say V equals 1, 7, negative 2. And W equals 2, 0, negative 1. Go ahead and find W cross V. Okay. Also, I'm not going to be posting this on the EdPuzzle slide, so I won't post the question. So write it down right now before I freeze it. Okay. All right. So I'm going to freeze it now. Hopefully this is written. All right, and you should be back having solved this already. So basically, quick and easy, how I'm going to do this, you know what, we're going to do W cross V. There's several ways to do this. Let's just create our 3 by 3, I, J, K. W goes on top because we are crossing it with V. And then V goes underneath, all right? And so if we want to find the cross product here, all right, we're going to have I times something minus J times something plus K times something. Okay? So when we look at I, this is the 2 by 2 that we're going to use. 0 minus negative 7 is positive 7. Okay? When we do J, just so you guys know, we're basically blotting out that, and we're creating our 2 by 2 using that. So we've got negative 4 minus negative 1. So negative 4 plus 1 is negative 3. Please keep in mind it's going to be negated then afterwards as well. Okay? Boom. And for K, okay, we would use this 2 by 2 determinant, 14. Very simple. So what is our vector? 7, comma, positive 3, comma, 14. Write it in vector notation. Okay? Just like that. All right, let's do another one. Vector A is 1, 3, negative 5. Vector B is 5, 0, 2. Go ahead at this time and find 2B crossed with A. All right, once again, I'm not going to be posting this on the EdPuzzle slide for the question when it prompts you, so you need to copy this down right now. I'll give you a couple seconds to do so. Okay, now I'm going to freeze it, and you're going to have to solve this. You're going to be looking for 2B cross A. All right, you should be back now. So I am actually going to solve this for you so you can see how you were supposed to have done it. Just for time's sake, I'm going to create my IJK right there. And guess what? I realized that I've got A on top. Well, what I'm solving, okay, what I am doing right now, just for a shortcut for the video purposes, is I'm actually doing A cross B. Right? If you look at it, as opposed to 2B cross A, I'm just doing A cross B. And then I'm going to use some properties to solve the rest of the answer. Okay? So let's do this real quick. I would be 3 times 2 minus 0 is 6. J, 1 times 2 is 2. Minus negative 25 is, so we've got 2 plus 25 is 27, but we've got to make it negative. So negative 27, okay? For K, we're just going to look at these 4 right here. 0 minus 15. And this is the answer to A cross B. That is not our cross product that we were looking for. So first, we have to keep in mind that this 2 can be pulled out using our properties, so this is really the same thing as 2 times B cross A. Well, what is B cross A? Okay, not flipping this, but it's the negative of this. So B cross A is going to be negative 6, 27, 15, and double that, and we get our answer, which is negative 12, 54, 30. Boom. Okay, hopefully that helps. I'll leave this up for a second. All right. Let's make this the last one of these that we're going to solve in this format. So why don't you guys at this time go ahead and find, again, I'm just coming up with these off the top of my head. 2, 3, negative 7. And we'll go with negative 4, negative 6, 14. Go ahead and find that cross product. And again, I'm not going to post this on the EdPuzzle slide, so copy it down right now in your paper as you're going through it. And then, but you are submitting your answer down to EdPuzzle, okay? So you do have to actually solve it and submit before you can go on. And I am still getting an idea of who got it correct and not. All right, I'm going to freeze it right now. All right, you should be back and ready to solve this. Not solve, but compute this cross product. I, J, K, 2, 3, negative 7, negative 4, negative 6, 14. Okay, so we've got I times 42. Okay, minus negative 42. Hold on. This is positive 42, because negative, negative, but we're subtracting it, a third negative. So we've got positive 42 minus 42. Okay, we'll see what happens here in a second. All right, we've got then minus j. Remember, it's always the opposite sign of this. Minus j times, let's check that one, 28. Okay. Minus 28, because this is a positive 28 that we're then subtracting off. Okay? I wonder what's going to happen with k. Maybe I, off the top of my head, created something special here. We'll see. So if we look at the 2 by 2 of k, we've got negative 12, positive 12. This is actually negative 12, but we're subtracting it. So we've got basically negative 12 minus another negative 12, or negative 12 plus 12, which is 0. Okay, so we've got 0i minus 0, or we'll say plus 0j, and then we'll say plus 0k. So what do you get when you have a vector that is in every single direction, their components go in a direction of 0? All right, you don't have a vector anymore. We're not going to ever write down the vector 0, 0, 0. This is not a vector. Okay, this is a location, or not really a location. This is a point at any location, technically. Because what we're saying is go 0 in the x, 0 in the y, 0 in the z from some starting value. Because vectors are movable from any location. So what we're really saying is wherever you are is where you are. It's just a point. Okay, not necessarily even a point that we know. It's just there is no direction. There's no vector. So what can we say if you cannot create a vector that is orthogonal to 2 other vectors? Because if you think of it, any 2 vectors you create, okay, you could technically turn them into, right off the same point, you could turn them into like an angle. Well, you could easily, right, any 2 vectors, if you impose them from the same starting value, okay, what you're able to do is say, well, that's 3 points. Well, 3 points make a plane. So any 3 points that are not collinear make a plane, okay? All right, I guess this is better, all right? So we've got one vector, another vector, okay? If they're in different places, that's fine, but if they're in the same place, technically starting value, we've created not 4 points, but we're sharing one, the start point. We've created 3 points that are not collinear, therefore they create a plane. And anything that's a plane is a flat sheet, which means there is a cross product that should be yielded from that, right? That makes sense. There should be some sort of a orthogonal vector that we can create from a sheet. That's the normal vector. But in this case, we can't, which means these two vectors are either in opposite or parallel direction, opposite or the same directions, meaning they're parallel either way. Meaning our 3 points are not looking like this, meaning they're looking like this, or I can't get my arms to spread that far, or like this, okay, or that, right? They are collinear. And if they're collinear, okay, we don't know where that orthogonality creates. In fact, if they're collinear, they are an axis, meaning there's actually 380 degrees of rotation around that. Think of it as a cylinder where you're shooting out from. We don't know where that normal vector would shoot out, okay? So there is no normal vector, or there is no cross product yielded in this case. There is no vector, in fact. So anytime you get this result, we know that our original vectors were parallel, which we know that now because this is the same thing. Oops, I just stepped on these cords, almost slipped. That equals -2 times that. Lambda is -2. Opposite direction, double the length. Okay? All right. Next thing I want you to do. You are given A cross B equals 2, 3, 7. I'm also going to tell you that 2C cross A is 8, -6, 4. All I want you to do is find A cross the quantity B plus C. Okay? So if you will, go ahead and write all of that down in your notes. Then I will pause it, and then you will solve it and submit your answer on EdPuzzle. Please keep in mind, once again, I'm not typing all of this into an EdPuzzle question. I'm just going to type in the answer choices for you, so you have to write it down on your paper. Okay? All right. Hopefully you have written that down by now. If not, I'll give you another like 10 seconds. All right, I'm going to pause it now. And you're back. Hopefully you have already solved this. Okay. If we want to find A cross B plus C, that's really saying I want to find A cross B and sum that up with A cross C. So this is actually what I'm looking for, is A cross B summed up with A cross C. All right. Well, I know what A cross B is. That's awesome. Okay, so I know one of my vectors is 2, 3, 7. I don't know this one. Oh, you know what? Check this out, though. We know a property. We can pull this out right there. All right? And in reality, what we have is now we know what C cross A is once we divide that 2 over on the other side. So C cross A is 4, -3, +2. Well, C cross A, that's not what I want. I want A cross C. Well, A cross C is the negation of this. So A cross C would be -4, +3, -2. And our final answer then becomes -2, +6, +5. Boom. Okay? If that was too fast for you, refer to this same video on YouTube, because I'm posting it on YouTube as well. Okay, so you can rewind and watch it several times. Next question, go ahead and write this down, and then I'll pause it again. Okay, I'm going to pause it now, so you should have written this down. All right, we're back, so hopefully you have answered this question. We know V cross A, we know A cross U. Oh, wow, that's a whole lot that we want to solve for. Okay, so in reality, I have 2U cross A, and I'm summing that up with, looks like 3V cross A. So just for simplistic purposes, this is really like saying I've got 2 times U cross A, and I'm going to add that to whatever 3 times V cross A is. Okay, that's really what I'm looking for. All right? V cross A. Oh, dang, that's awesome. I actually know. Oop, wrong color. That didn't work. I actually know what V cross A is. That goes right there. 2, 2, 2. So this is 6, 6, 6. Hopefully I do not get smited. All right. A cross U. Oh man, I want U cross A. Okay, so negate that. The negation of this is -4, +1, and 0. Okay, and I want to double that. Okay, so I've got -8, +2, and 0 when I double that. Now I just add them together, and I get a final vector solution of -2, +8, +6. Okay, -2, +8, +6. All right, final questions. Identify each of these pairs of vectors. So these are 2 questions. This will be the first one, and this will be the second one. Identify them as either parallel, perpendicular, or neither. And I should really say parallel, orthogonal, or neither. So I'm going to let you copy them down for a minute. Copy both sets because the questions are going to be continuous. And then you're going to have to submit both. Okay, you should have them copied down now. So I'm going to go to the slides where I freeze them, and then you can enter your answers. All right, we're back. Looking through this, the only way we can test if they are parallel, perpendicular, or neither, parallel, orthogonal, or neither, is if we either do cross product or dot product, or we look for a scalar. Okay, so this first one, if we go ahead and we find the cross product, so if I guess let's go with the dot product first. Okay, so let's test the dot product just because that's the easiest thing to test. So we've got -7, okay, -343, don't think this is going to work, and then another large negative. Nope, that does not equal 0. Since the dot product does not equal 0, we know that they are not orthogonal, okay? Remember, that was one of our rules. Okay, so here, let's try the dot product. Okay, so 30, so that's 5 times 6, -32, -2 times 16, and then +2. That actually equals 0. Okay, so we know that this set is orthogonal. We know that this is not orthogonal, so now we just need to test if it's parallel. So hopefully you took the cross product of it, and you found that the cross product does equal 0, meaning they're parallel. Or you just noticed that, wait a second, if I multiply this by lambda, such that lambda equals -7, I then end up with that. Okay? -7 times that, -7 times that, and that is our other resultant vector. Okay, so our other vector that we were testing out with the result of this concept. So there we go, parallel. All right, enjoy.